So this unit, we're going to study gas laws, and we'll look at how gases behave, and we'll look at how do they behave when we change like the volume, the temperature, or the pressure of that gas. And so today we're going to learn 3 gas laws. They are the simple ones. Okay, so we'll introduce those 3 simple ones. We'll do some practice problems, then we'll do a lab where we look at them in real life. Okay. So our first gas law we're going to learn is called Boyle's law. Okay. The fancy wording for Boyle's law is for a given mass of a gas at a constant temperature, the volume of the gas varies inversely with pressure. So if you're sitting there like, Miss Wilcox, I don't even know what that means. I simplified it in the bold here. So what that means is if you increase the volume, you're going to decrease the pressure. Or if you're going to decrease the volume, you're going to increase the pressure. And let's think about why this law is what it is. So first, let's just record, what is pressure? Okay. And we saw this last week when we studied the kinetic molecular theory. But I actually want to write it down, okay? So pressure is caused So it's caused by collisions with the container. Okay, so when we talk about pressure, it's just caused by collisions with the container. So if we talk about the pop can, it's just collisions of the gases inside that pop can is what causes pressure. If we're talking about balloons, then it's just the collisions inside the balloon. What if we're talking about the room here? What's the container of this room? Okay, the walls. Okay, so whatever the container is, it's the actual collisions with the wall of that container is what causes pressure. So then let's use kinetic molecular theory to make sense of this. So if you increase the volume, you make the space bigger, are you going to have more or less collisions? Less. Okay, so that's why you have less pressure, there's going to be less collisions. Okay. Then let's say you decrease the volume, so you make the space smaller. Are you going to have more or less collisions? More, which is why you're going to have a higher pressure. Okay. And then Boyle's law is this equation right here. So P1 V1 equals P2 V2. Make sure you write this equation down in your notes. Okay. And then what do you think P stands for in that equation? Pressure. Okay, P is going to stand for pressure. What do you think V is going to stand for? Volume. Any guesses what the number 1 is going to stand for? No. What? In math class, have you used any equations with 1 and 2 in them? Yeah. Okay, so the 1 is going to stand for initial, or your starting pressure or volume. And then 2 is going to stand for final, or your ending volume or pressure. So before we jump into calculations, I just want to talk about units for pressure because that's something we haven't measured before. Okay. So when we look at gas laws, we can measure pressure in 4 different units. So I need you to be familiar with these. Okay, so atmospheres, we just abbreviate with ATM. Okay. We can use something called torrs, which there's no abbreviation. Torr is just torr. Okay. We might use something called kilopascals, which is KPA for abbreviation. And then 4th, we have millimeters of mercury, which is mmHg. Okay. So for these, you just need to be familiar with them enough that if you see them in a word problem, you know it's a pressure. Okay. And then I do want you to write down the conversions. So sometimes you might have to convert from one pressure unit to the next. So go ahead and write these down. So 1 atmosphere is equivalent to 760 torrs, okay. Which is also equivalent to 760 millimeters of mercury, which is also equivalent to 101.3 kilopascals. So now we're going to do a couple practice problems. I know this first one's really easy. Follow this whole process with me, though. So I want to show you how should we set these up. Okay. So we have a gas at 1 atmosphere, and the volume changes from 5 milliliters to 10 milliliters. What will be the pressure? Okay. So the first thing we have to do, we just have to figure out and kind of organize the information. Okay. So how many different numbers are given in that word problem? 3. So do we need a way to just kind of like organize and understand what info was given to you? Yeah. Okay, so we're just going to list all of that given info. So what's the first number you see? Okay, so 1 ATM, which is 1 atmosphere. An atmosphere is a unit for pressure. Okay, and it's the first one, so P1 is 1.0 atmospheres. All right, and then we see the volume changes from 5 to 10 milliliters. So what's the starting volume? 5. So V1 is going to be 5.0 milliliters. And then 5 milliliters is going to change into how many? 10. So V2 is going to be 10 milliliters. And then what are we solving for? Okay, so I'm going to put P2 and I'm going to put the question mark there because that's what I'm solving for. So step 1 is to always start here and just list the information you know. Right now you know you're going to use Boyle's law because that's the only one we know. However, you're eventually going to get to the point where you don't know which equation to use. So then this is how you know. So then you're going to look at, well, what equation has P1, V1, P2, and V2 in it? And what's the name of that equation? Boyle's law. Okay. So then I just like to write it. So Boyle's law, I'm going to use P1, V1 is equal to P2, V2. And now I'm just going to plug in the numbers in that exact same order. So for P1, I'm going to write in 1.0 atmospheres. For V1, 5.0 milliliters. P2, I'm just going to keep it as P2 since that's what we're solving for. And then for V2, 10.0 milliliters. So on this step, do you see how I kept the same formula? I just now plugged in numbers. Okay. Okay, so now we have to solve for P2. How do we get P2 by itself? Good. So I'm going to divide both sides by 10 milliliters. Okay, if you look at your units, do you see how milliliters have canceled? Okay. Now what's 5 divided by 10? 5 divided by 10. 0.5. Right. 5 divided by 10. 5 over 10 is half. So 0.5. If you look at units, milliliters canceled. What's the only unit that didn't cancel? ATM. So that's your unit for P2.
So whatever unit doesn't cancel is your answer unit?
Mm-hmm. Is it another way to check your unit? If P1 is, oh, I meant to be in the red. If P1 is in ATMs, P2 should be in ATMs. Our second example, a balloon contains 30 liters of helium gas at 100 kilopascals. What is the volume when the balloon rises to an altitude where the pressure is only 25 kilopascals? Okay, so what's the first thing we're going to do? Okay, we're just going to organize that info. So what's the first number you see?
30.
Okay, 30L. What do you think L stands for? Liters. And liters is a unit for? Volume. Okay, so V1 is going to be 30 liters. What's the next number you see?
100.
Okay, 100. And what's the unit?
Kilopascals.
Okay, the kPa are kilopascals, and that's a unit for?
Pressure.
Okay, pressure. So P1 is 100 kPa. What's the third number you see?
25.
25 kPa, and kPa is? pressure. So P2 is 25 kPa. And then what are we solving for?
Volume 2.
Okay, so V2 question mark. Okay, I promise you, always start here. So take the time, write down all of your variables, because then eventually this is how you're going to know what equation to use. So then now what equation do you know that has P1, V1, P2, and V2 in it?
Boyle's law.
Okay, so Boyle's law, so we're going to use P1, V1 equals P2, V2. And now I'm just going to plug in those numbers in that exact order. So we have 100 kilopascals times 30 liters equals 25 kilopascals times V2. Okay, now what's the next step?
Plug 'em in.
Okay, plug them in. So how do I actually solve for V2?
How do you divide?
Okay, what am I dividing? Okay, so divide both sides by 25 kilopascals. Okay, so everybody type this into your calculator. So I would do 100 times 30, then hit equals, and then divide that by 25.
What if my calculator would work?
Okay, 120. What's your unit? Okay, liters. The way you check your unit, do you see how kilopascals cancel? Okay, liters didn't cancel, so that's your unit. A secondary way to check is if V1 is in liters, what should V2 be in? Liters. Okay, so now we're going to move on to our second gas law. It's called Charles's law. So Charles' law just says that the volume of a fixed mass of gas is directly proportional to its Kelvin temperature as long as pressure is kept constant. So an easier way to word that, if you increase the temperature, you're going to increase the volume. If you decrease the temperature, you're going to decrease the volume. And then they're directly proportional. So it's more than like if just one goes up, the other goes up. If, let's say, temp goes up by 2, how much does volume go up by? 2. Let's say we cut temperature in half. What happens to volume? Cut in half. Okay. So they change proportionate to each other. And then your equation for Charles' law is V1 over T1 is equal V2 over T2. Okay. So make sure you get that equation down. What do you think the V stands for? Volume. What does T stand for? Okay, temperature. This time, unit matters. Temp has to be in Kelvin. So if you want, you can write yourself a little note. So temp has to be in kelvins. And then the 1s and the 2s are still your initials and your finals. Okay, this time, when we talk temperature, temperature has to always be in Kelvin. So to convert to Kelvin, you just take your degrees Celsius plus 273. Okay. So go ahead and copy down how we get to Kelvin. So just Celsius plus 273. And then why Kelvin, you think?
It's the agreed upon scientific temperature.
It is agreed upon, but it's better than just agreed upon.
To make math easier and to make it more accurate.
Okay, it does make math. Look at Charles's law. What is Charles's law equation?
Division.
V1 over
Temperature.
T equals V2 over T2. What's the coldest temperature in Celsius you can think of?
I have no idea. Because I don't look at it. I don't order that.
Coldest temperature you can think of in Celsius? Forever. Forever.
Some of you, I see it. Some of you, I think, are getting it. Throw out like a cold number in Celsius. Okay, water freezes at 0. Can we get colder than 0 degrees? Okay, so can we get to like minus 40 degrees? Okay, if we look at this equation, can you divide by minus 40? Okay, does anyone know what's special about the Kelvin scale? All positive. What's the coldest value you can get?
0.
0 theoretically, right? So you can't divide by a negative number, so you can't be in Celsius. Okay. Also, the way we measure Kelvin is like it's based off its kinetic energy. So the relationship is only true if we're in Kelvin. Okay, so let's do an example using Charles' law. Okay. So this time we have a balloon. It's inflated in an air-conditioned room at 27 degrees Celsius, and it has a volume of 4 liters. The balloon is then heated to a temp of 57 degrees Celsius. What's the new volume? Okay, so this one, we're going to start it the exact same as the other one. So first we just have to organize all of these numbers. So what's the first number you see?
27 Celsius.
Okay, and Celsius is a unit for?
10.
Okay, so T1 is 27 degrees Celsius. Can you ever be in the unit Celsius?
No.
No.
You have to convert it to
Okay,
Kelvin.
so let's convert it to Kelvin right now so we don't forget later. So you're just going to add 273 to that number. So what's 27 plus 273? Okay, so our temp is actually 300 Kelvin. What's the next number you see? Okay, 4 liters, and liter is a unit for? Okay, so V1 is 4.0 liters. All right, the balloon then gets heated to a temp of 57 degrees Celsius. So what's that? T2 is 57 degrees Celsius. And can you be in Celsius? Okay, so what are we going to do with that number right away?
Convert it to Kelvin. 270.
Okay, so do you do it like right off the bat, do it so then you don't forget. So what's 57 plus 273? Okay, so the T2 is actually 330 Kelvin. And then what are we solving for? Okay, V2, and I'm just going to put the question mark. Okay, so now what equation do you know that has T1, V1, T2, and V2 in it? Okay, so we know Charles' law has all of those. So I just like to rewrite it. So Charles' law is V1 over T1 equals V2 over T2. And now I'm just going to plug in those numbers in that exact order. So V1 is 4.0 liters. T1 is 300 Kelvin. V2 is what we're solving for, so I'm keeping it as V2. And then T2 is 330 Kelvin. Okay, are you with me so far? Okay, you may do algebra to solve for any of your variables. When it's in the numerator, it's easier. People tend to struggle if you're solving for something in the denominator. So if you love your algebra, you're good at algebra, you may always do algebra to solve for these. If you don't love algebra or you're not great at it, we're just going to cross multiply. Okay. So to cross multiply, you're always going to start in the diagonal that doesn't include what you're solving for. So we're going to start in this diagonal. So we're going to take this 4 liters and this 330 Kelvin, and you're going to multiply those. Okay. So practice with me. So multiply 4.0 times 330, and then you can hit equals and get an answer. And then whatever diagonal has the variable you're solving for, you're going to divide by that number. Okay. So then once you have your answer of that first diagonal, then you're going to divide it by 300 in this scenario.
So after you multiply, you divide it by.
Divide it by 300.
I thought we would multiply by 300.
Or? Okay, and then unit-wise, again, you can look, if you were to do algebra, you would see the K's cancel. If you cross-multiply, units don't show you how they cancel, but you can just match them. So V1 is in liters. What does V2 have to be in?
Liters.
Liters. Okay, Last gas law for the day. So give me your attention up here. Last one. It's called Gay-Lussac's law. This time, the pressure of a gas is directly proportional to its Kelvin temperature as long as volume's constant. So if pressure goes up, temperature goes up. If temp goes down, pressure goes down. Okay. And so the equation for Gay-Lussac's law is P1 over T1 equals P2 over T2. So make sure you get that equation down. What does P stand for? Pressure. What does T stand for?
Temperature.
Okay, temp. And again, just like the last one, what unit does temp have to be in?
Kelvin.
Okay, so again, make sure you're converting that temp to Kelvin. Okay, so this time we have a gas left in a used aerosol can, and it's at a pressure of 100 kilopascals at 27 degrees Celsius. If the can is thrown into a fire, what will the internal pressure of the gas be when it reaches 927 degrees Celsius? Okay, so what do you think the first step is?
Organize.
Okay, we're just going to organize all of that information. So what's the first number you see? Okay, 100, and what's the unit? Okay, kPa, which is kilopascals. What's that a unit for?
Pressure.
Okay, pressure. So P1 is 100 kPa. What's the next number you see? Okay, Celsius. So that's a unit for?
T.
Okay, so T1 is 27 degrees Celsius. And can you ever be in Celsius?
No.
Okay, so what are we immediately going to do?
Add 273.
Okay, so we're going to convert it to Kelvin by adding 273. So what's 27 plus 273?
300.
Okay, so we'll convert it to 300 Kelvin. What's the next number you see?
900.
Okay, 927 degrees Celsius. So what is that?
T2.
Okay, so T2 is 927 degrees Celsius. And what are you immediately going to do with that unit?
Turn it to Kelvin.
Okay, turn it to Kelvin. So what are we getting for T2?
1,200.
All right, and then what are we solving for?
P2.
Okay, P2, question mark. Okay, so then we ask ourselves, what equation do we know that has P1, T1, P2, and T2 in it?
Charles one.
No,
Or wait, no. Yeah, it's the other one.
Okay, Gay-Lussac, and again, I just like to write it down. So P1 over T1 equals P2 over T2. Okay, what's the next step? Okay, we're going to actually plug in those numbers. So we'll take 100 kilopascals all over 300 Kelvin. P2, I'm just keeping it as P2 because that's what I'm solving for, all over 1200 Kelvin. Okay, if you love algebra, can you just solve this algebraically?
Yes, you can.
Okay, if you don't love algebra, what can you do?
You can do it.
multiply and then divide.
Okay, so cross multiply, always start at the diagonal that doesn't have whatever you're solving for in it. Okay, so multiply 100 times 1200. Push equal. Get an answer. And then whichever number is in the diagonal that you're solving for, you're going to divide by that number. Okay, so then now divide it by 300. What are we getting?
400.
400 even. Okay, and then what do you think your unit is for P2?
KPA.
Okay, kPa, it needs to match whatever P1 was.